Last episode, we set up our Ubuntu server VM and SSHD into it from Windows. That blinking cursor you see right now, that's where every demo in this series happens. No GUI, no crutches, just the shell. Chapter 1 is about orientation. When you land on a comprehensive system or any Linux box, very first thing you need to know is where am I, what's around me, how do I move, and how do I create and run scripts. That's exactly what we are covering today. The book frames all of this from an offensive security perspective. You just compromise a system and you are dropped into a shell. I am going to keep that framing throughout. It makes the commands feel purposeful rather than academic. Imagine you just popped a shell on a system. The first feeling is disorientation. Where the hell are we? The first command you run on any system you just landed on on is is this pwd print working directory. It tells you where you are right now in the file system. We are in home clover paste our home directory on a real compromise box. This might be temp where slash www or wherever the exploit dropped us. PWD is our anchor. Now we know where are we, but what's here? We list the contents of the directory. We use ls. Okay, ls gives us a list, but no details. Size, permissions, who owns these files, that's original. We need to ask nicely. We'll ask ls l. At the L flag, that's the lowercase l for long. This is the format you actually want. The left column, that string of letters and dashes, those are those are the file mode bits. We will break those apart in details in a few minutes. For now, entries starting with D are directories, entries starting with a dash are files. Linux has a trick. Files that start with a dot are hidden from a regular ls. Shell configures, SSH keys, history files, all hidden by default. On a target system, these are gold. The hyphen A flag reveals everything. It is ls hyphen A. There they are. Dot bash rc shell config. Dot bash history. Every command this user has typed in a pentest, that history file is incredibly valuable in. We can combine flex. ls-la gives us the long format and shows hidden files. This is the one I run almost every time I learn something new. And before we move on, let me introduce comments. In Bash, anything after a hash symbol on a line is a comment. Bash ignores it completely. You will see me use them throughout the explain what a command does. You will see the wrong format, show hidden files before a commit this for to memory. They are muscle memory for any Linux operator. We know where we are and what's here. Now we want our own workspace to work in. Let's create a directory, a folder named bash course. We will do all our work in here throughout the series. It ls confirms it exists. Now let's go inside. CD stands for change directory. Pass it the name of where you want to go. Move into bash. Folder. See how the prompt updated. It now shows we are inside bash underscore course. But let's prove it with pwd. Okay. Two dots mean the parent directory one level up. So going back up with cd, two dots means the parent directory one level up. So cd dot takes us back to where we came from. No, one level up. And cd on its own with nothing after it always takes you straight back to your home directory, no matter where you are. Echo is that simple. It prints whatever you give it back to the terminal. Watch. Echo. Hello. World. Echo is going to be everywhere in our script. It's how script talk to the person running them. Progress messages, error reports, results. We will also use it to write content into files later. Quick this. You can also redirect echoes output into a file with the symbol, with the greater than symbol. We will use this a lot later. It just reads a file, so no need to worry about the new command. To write a base script, we need a text editor. On Linux, you have Vim, Nano, Emacs. I'm going to use Nano because it's beginner friendly and shows its own controls at the bottom of the screen. Vim is amazing, but it has its own learning curve. We don't need right now. Let's create our very first script. We'll call it hello.sh. The .sh extension isn't required by Linux, but it tells humans and tools that this is a shell script. The very first line of every bash script must be the Shebang. It's this exact string hash ex, exclamation mark bin hyphen bash. No spaces, no variation. Okay, what does this actually do? When Linux tries to execute a file, it reads the first two characters. If it says hash and hash exclamation called a shebang, it reads the rest of that lines as the interpreter path and passes the whole script to it. Without this line, Linux doesn't know what to do with the file. Under the shebang, we write our script. We'll keep it simple. Print a message. To save it to save in nano, press Ctrl O. That's the letter O, not 0. It asks you to confirm the file name. Just hit enter to keep hello.sh. Then Ctrl X to exit and get back to the terminal. Good. We are back at the prompt. Let's confirm the file is there. ls-l. Now let's run it. To run a script in the current directory, you use dot slash before the file name. That dot slash tells the shell look in this directory, not the system path. Permission denied. Linux just stopped us from running our own script. Why? Because Linux is not stupid. Just because a file exists doesn't mean it allowed to run as a program. We have to explicitly grant it execute permission. This is the file mode based system. Okay, look at the ls-l output. That first column, the string of r, w, x, and dash each. That's the permission string. Let me break it down. Each of those three groups can have three permissions: R for read, W for write, X for execute. A dash means that permission is absent. So right now, hello.sh has rw-rw-r. The owner us can read and write it, but not execute. Nobody can execute it. That's why it was denied. We need to add X for the owner. Chmod change mode modifies those bits. The simplest way, change mode plus X followed by the file name. The plus means add this permission. X means execute for all users. Look, it changed to RWXRWXR. The X bits are set, and notice one most terminals the file name turns green. That's the shell telling you this file is executable. You can be more precise with symbolic mode. U is user or owner, G is group, O is others, A is all three. There's a second way to use chmod. octal numbers. Each permission has a value. R is 4, W is 2, X is 1. You add them up to get the permission for each group. So three digits, one for user, one for group, one for others. 755 means RWX for owner, R-X for group, R-X for others. You will see this everywhere. Before we move on, there are three special permission bits that you will encounter in the wild. I want you to know what they are, even if we don't use them right now. SUID, set user ID. When set on an executable, the program runs as the file's owner, not the person who launched it. The classic example is uh, slash user slash bin slash pass wd. It needs root access. Notice the S in the execute bits. SGID, same idea but uses the file group. Useful for shared project directories. Sticky bit on a directory like temp users can only delete their own files, even if they have rewrite access to the directory. Two more quick ones. Ch.on changes who owns a file. Ch group changes the group. And umask controls the default permission for new files. When a new file is created, Linux subtracts the umask from the maximum to get the default. A umask of 0 to 2 means new files get 644, new directory gets 755. The math 666 minus 0 to 2 equals 644. 777 minus 0 to 2 equals 755. Okay, we gave it execute permission with chmod. Now let's actually run it. There it is. Congratulations. You just wrote and executed your first bash script. It's simple, sure, but the mechanics you just used, create a file, write a shebang, make it executable, run it, those are the exact same mechanics behind every script in this series, no matter how complex. By the way, there is another way to run a script without chmod. You can call bash directly and pass the script as an argument. This bypasses the execute bit check. Same output, useful to know, right? But the dot slash script dot sh approach is more standard. Stick with that. One more quick command before the exercise. Nano creates a file and opens it for editing. But sometimes we just want to create an amplifier without opening up any editor. That's what touch is for. 0 bytes and empty exists. Touch is also used to update a file's timestamp without changing its content. But in scripting, we mostly use it to create placeholder files quickly. Time for exercise 1. Every chapter ends with an exercise that brings everything we cover together. Here's what setup.sh needs to do. You have in exercise 1, setup.sh requirements. Print creating your personal folder. Create a folder named pouring underscore folder. Go into that folder. Create an empty file called useless.txt. Print setup complete. Pause the video here and try it yourself first. No shame in struggling. Struggling is where you actually learn. Come back when you want to see the solution. Alright, let's build it together. Open Nano with file name. Line 1, always the shebang. Then each requirements maps directly to a command we learn. Notice how each line maps exactly to one requirement from the spec. That's code scripting. Clear one task per line. No magic. Save with Control plus O, enter, then Control plus X. Make executable and run. Here. Okay, so we chmod plus X setup.sh. Now we will run setup.sh. Two lines of output. Let's verify everything it has supposed to so means it has supposed to do actually happened. Okay, so let's wait for the day. Do we see boring folder? Yes, do. Now ls boring folder. Okay, so boring folder exists. Useless.txt is inside it. The script did every single thing was supposed to do. This is the verification mindset. Don't just run a script and assume it worked. Check the output. Quick note, when a script runs cd, it changes directly inside the script's process. When the script exists, your terminal is still in its original location. The cd in the script doesn't affect your shell. This trips people up constantly. Okay, so we clicked with pwd. We are still on bash course, not on the boring folder. Are we? So here is everything covered. Run through this yourself in your terminal until they feel natural. Next chapter, logic and intelligence. Our scripts so far just run commands in order. Chapter 2 is where they get smart. Variables, building user input, if else decision loops. That's where bash stops being a command list and starts being an actual program. Do the exercise, don't skip it. The exercise is where the concept actually stick. If you got stuck or your script behaved unexpectedly, drop it in the comment with what you tried. Subscribe for chapter 2. See you there.